Let's talk about Bohr's postulates and also expression for radius of nth orbit. Okay, let's first talk about Bohr's postulates. Bohr gave us two postulates. One is Bohr's quantization condition. Bohr's quantization condition. Another one is Bohr's frequency condition. His quantization condition was an electron cannot revolve around the nucleus in all possible orbits. If there is a nucleus, if there is an electron, if it wants to revolve around the nucleus, it cannot revolve in all possible orbits. It can revolve around the nucleus only in those allowed or permissible orbits where the angular momentum of the electron, angular momentum L, or you can also say mvr, angular momentum of an electron should be equal to nh by 2 pi. Only then in that orbit electrons are allowed. Okay, this is Bohr's quantization condition. Okay, so Bohr's quantization condition is electrons cannot revolve around nucleus in all orbits, only they are admitted or permitted in orbits where the angular momentum of electron L, that is mvr, is equal to nh by 2 pi. The second condition is Bohr's frequency condition. And what is Bohr's frequency condition is, when an electron jumps from a higher orbit to a lower orbit, if an electron jumps from a higher orbit to a lower orbit, whatever that energy difference is there, no? Yeah, energy is equal to h nu, we know, h nu. Now it is higher orbit E2 to say lower orbit E1. That energy difference E2 minus E1, which will be definitely released as energy h nu. This is Bohr's frequency condition. Okay. We most probably will be using Bohr's postulates while deriving the radius of nth orbit. Now let us go into deriving the radius of nth orbit, which is a 10-mark question, or suffix n. Okay. Think of this. What is nucleus? A nucleus consists of protons and neutrons. Okay. Forget about neutrons who are mass, who are only mass and no charged particles. So talk about Z number of protons, each having charge say equals to E, is present inside the nucleus. So I'm going to call this as nucleus, which comprises Z number of protons, each of charge E. Okay. Suppose I consider an electron revolving around in the first orbit. Can I not call this as radius 1 because it is the first orbit? Yeah. So if there is an electron revolving around in second orbit, I can call this distance as radius 2. So same way, if we talk about electrons say revolving in the nth orbit, I can call this distance as r suffix n. So this becomes the radius of nth orbit. First of all, you have to understand that this is what we have to find out, the radius of nth orbit. Okay. Now, getting to the question now. Let's talk about the diagram now. It is Z number of positive charges E versus an electron present in the nth orbit. Call this distance as r suffix n. Okay. We have studied according to Coulomb's law. Okay. Let this be charge of an electron E. So according to Coulomb's law, the electrostatic force is given by 1 by 4 pi epsilon naught charge 1 q1 q2 by r square. Remember? Yeah. So we are making use of that now. So here the force is equal to 1 by 4 pi epsilon naught. Instead of q1 I'm going to write z into E, because it is nothing but the charge inside the protons, and into q2, that is charge of electron, by distance between them, as it is nth. I'm going to call this like this. Okay. Now, what is the motion of electron around the nucleus? The path is a circular path? Yeah. So I have to talk about centripetal force now. I'm going to say that this electrostatic force is responsible for electron revolving in circular orbit. Okay, what is circular orbit? Centripetal force mv square by r. Having a suffix n, we're going to say mvn square by rn is the centripetal force. Okay, but we also know that instead of v, I can write r omega. So vn is rn omega n. Substituting this in this, I'm going to end up getting m rn square omega n square by rn, of which one rn can cancel off. So the centripetal force is m rn omega n square. So I'm going to say m rn omega n square is the centripetal force, or the circular force, which was actually provided by our electrostatic force 1 by 4 pi epsilon naught ZEE, so ZE square by Rn square. Or I will say omega n square, keeping one side, rest of the people coming to the other side, 1 by 4 pi epsilon naught ZE square by m Rn, under Rn square is there, so Rn cube. Okay. Remember Bohr's postulate? We haven't used it yet. Okay. Let me write the first postulate of Bohr's, which says L, that is angular momentum, that is mvr, having suffix n here, mv and rn, should be equal to nh by 2 pi. Then only the electrons will revolve around in those orbits. So instead of vn, as we can substitute r omega, I'm going to write vm into rn omega n into rn, which is nh by 2 pi. Or I can say omega n can be written as nh by 2 pi. This will come down here, no? So it will become m rn square. How about squaring this on both sides? Then it will become omega n square equal to n square h square by 4 pi square m square rn power 4, right? So it's going to become omega n square is equal to n square h square by 4 pi square m square rn power 4. Taking this omega n square, comparing with this omega n square. So it is this compared with this, right? I can take this and compare with that, right? So I can say I can compare with this. So it's gonna be, which is equal to n square h square by 4 pi square m square rn power 4. Rn cube will cancel with this, 1m will cancel with this, 1 pi will cancel with this, 4 can cancel with this, leaving out n square h square by pi m rn is equal to ze square by epsilon naught. Okay, I'm going to say n square h square by pi m rn is equal to ze square by epsilon naught. Okay, we want only rn, right? So rn, which can go this side, this can go this side, so it will become rn is equal to n square h square epsilon naught by Z e square pi m, right? Z e square pi m. So this is going to be radius of nth orbit formula. Okay. Now, what if I talk about Z is equal to 1, that is hydrogen atom? Then radius of nth orbit will be n square h square epsilon naught by e square pi m. In that case also, what if I talk about the very first orbit? Okay, before that, we know the value of h, we know the value of epsilon naught, we know value of e, pi and even m. Oh, because of all this, if I calculate by substituting all the values, it's going to be n square into 0.53 Armstrong after calculation. Okay, this is general formula, radius of nth orbit. What if it is the first orbit? Then R1 is 1 square into 0.53 Armstrong, which means radius of the first orbit is 0.53 Armstrong. This is called Bohr's or Bohr radius. This finishes radius of nth orbit.